Question 1. The evaluation methodology shows that a database designed for a customer order system in DB2 needs to be assessed for its adherence to relational database principles. The current design exhibits repeating groups of order items within a single order record and also contains transitive dependencies, where non-key attributes are dependent on other non-key attributes. Considering the need for data integrity and efficient data management, which normalization level best addresses these identified issues while remaining practical for typical application performance? Option A. Achieving third normal form 3NF by eliminating repeating groups and transitive dependencies. Option B. Stopping at second normal form 2NF to remove partial dependencies but not transitive ones. Option C. Maintaining first normal form 1NF by only ensuring that each column contains atomic values. Option D. Aiming for Boyce Codd normal form BCNF to address all functional dependencies, even if it leads to more tables. Correct answer is A. Achieving third normal form 3NF by eliminating repeating groups and transitive dependencies. Explanation. This scenario presents a professional challenge because it requires understanding the fundamental concepts of database normalization and its impact on data integrity and performance within the context of DB2 1. The challenge lies in selecting the most appropriate normalization level for a given set of requirements, balancing the benefits of reduced redundancy against potential performance implications. Careful judgment is required to avoid overnormalization or undernormalization, both of which can lead to suboptimal database design. The correct approach represents best professional practice because it aligns with the core principles of relational database design as understood within the DB2 framework. Achieving third normal form 3NF is generally considered a good balance, ensuring that data is organized efficiently, redundancy is minimized, and data integrity is maintained through the elimination of transitive dependencies. This leads to more robust and maintainable database systems, which is a key objective in professional database administration and development. An incorrect approach that stops at first normal form 1NF would fail to eliminate repeating groups and would lead to significant data redundancy and potential update anomalies. This violates the principles of efficient data storage and integrity, making data management more complex and error-prone. An incorrect approach that attempts to achieve a higher normal form, such as Boyce Codd normal form BCNF, or fourth normal form 4NF, without a clear business need or understanding of the performance trade-offs, could lead to overly complex table structures and potentially slower query performance due to increased joins. This demonstrates a lack of practical application of normalization principles and an oversight of performance considerations, which are critical in a production environment. The professional reasoning process for similar situations should involve a thorough understanding of the data's characteristics, the application's requirements, and the trade-offs associated with different normalization levels. This includes analyzing dependencies, identifying potential anomalies, and considering the impact on query performance and data maintenance. A systematic approach, starting with the basic normalization forms and progressing as needed, while always keeping performance and maintainability in mind, is crucial for making informed design decisions. Question 2. Compliance review shows that an application accessing sensitive customer financial data stored in DB2 is currently relying on application-level checks to restrict access to specific columns containing personally identifiable information, PI. This approach has been flagged as a potential security risk. Which of the following strategies best addresses this compliance concern within the DB2 framework? Option A. Enhance the application's code to include more complex validation routines for data access requests. Option B. Temporarily disable certain security auditing features in DB2 to improve the performance of the application's data retrieval. Option C. Implement row and column access control RCAC within DB2 to define granular access permissions based on user roles and data sensitivity. Option D. Document the existing application-level security measures and assume they are sufficient until a security incident occurs. The correct answer is C. Implement row and column access control RCAC within DB2 to define granular access permissions based on user roles and data sensitivity. Explanation. This scenario is professionally challenging because it requires a nuanced understanding of how DB2 One's data security features interact with application logic, particularly when dealing with sensitive customer information. The challenge lies in balancing robust security with the practical needs of application functionality and user access, all within the strict confines of regulatory compliance. Careful judgment is required to ensure that security measures are effective without hindering legitimate business operations or creating new vulnerabilities. The correct approach represents best professional practice because it directly addresses the identified vulnerability by leveraging DB2 built-in security mechanisms, specifically row and column access control, RCAC. RCAC allows for granular control over data access based on user roles and data sensitivity, ensuring that only authorized personnel can view or modify specific data elements. This aligns with the principle of least privilege, a fundamental tenet of data security and regulatory compliance, which mandates that users should only have access to the data necessary to perform their job functions. Implementing RCAC directly addresses the regulatory requirement to protect sensitive customer data from unauthorized disclosure. An incorrect approach that relies solely on application-level security is professionally unacceptable due to several regulatory and ethical failures. Firstly, it creates a single point of failure. If the application's security is compromised, all data becomes vulnerable, violating regulations that mandate robust data protection. Secondly, it often leads to inconsistent security enforcement, as different developers might implement security checks differently, creating loopholes. This inconsistency is a direct contravention of the principle of uniform and effective data protection required by regulations. Furthermore, relying on application logic for security can be bypassed by individuals with direct database access, even if they are not intended to see sensitive data, leading to a breach of confidentiality and trust. Another incorrect approach, which involves disabling security features to improve performance, is a severe regulatory and ethical failure. Performance optimization should never come at the expense of data security, especially when dealing with sensitive customer information. This action directly violates data protection regulations that mandate the implementation of appropriate technical and organizational measures to ensure a level of security appropriate to the risk. It demonstrates a disregard for customer privacy and a failure to uphold professional responsibility, potentially leading to significant legal penalties and reputational damage. The professional decision-making process for similar situations should involve a thorough risk assessment of data assets, identification of sensitive data, and a comprehensive understanding of applicable regulations. Professionals must then evaluate DB2 security features, such as RCAC, to determine the most effective and compliant method for protecting that data. This involves considering the trade-offs between security, performance, and usability, always prioritizing regulatory compliance and data integrity. When faced with a security gap, the default should be to strengthen database-level controls rather than relying on less secure application-level workarounds or compromising security for performance. Question 3. The monitoring system demonstrates a sudden and significant increase in the number of failed login attempts for a critical database table originating from an unusual IP address range. Option A. Apply a broad security patch to all database servers without confirming the specific vulnerability. Option B. Initiate a detailed log analysis to identify the specific user accounts targeted, the exact timeframes of the failed attempts, and any patterns that might indicate a brute force attack or a misconfigured application. Option C. Immediately roll back the database to the last known stable backup to prevent any potential data corruption. Option D. Wait for end users to report any login issues before taking any action. The correct answer is B. Initiate a detailed log analysis to identify the specific user accounts targeted, the exact timeframes of the failed attempts, and any patterns that might indicate a brute force attack or a misconfigured application. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires immediate action based on an anomaly detected by a monitoring system, without complete certainty of the root cause. The challenge lies in balancing the need for prompt intervention to prevent potential data corruption or unauthorized access against the risk of disrupting legitimate operations or implementing an unnecessary fix. Careful judgment is required to assess the severity and likelihood of the detected anomaly. Correct approach analysis. The correct approach involves a systematic investigation to identify the precise nature of the anomaly. This aligns with best professional practice by prioritizing data integrity and system security, which are fundamental principles in database management. Specifically, it adheres to the principles of due diligence and responsible system administration, ensuring that any action taken is informed and justified. This approach minimizes the risk of unintended consequences and ensures that resources are applied effectively. Incorrect approach is analysis. Implementing an immediate rollback without further investigation represents a regulatory or ethical failure because it assumes a problem without confirmation. This could lead to the loss of valid transactions or data, violating principles of data integrity and potentially contravening data retention policies. It also demonstrates a lack of due diligence in troubleshooting. Applying a broad security patch without understanding the specific anomaly is another failure. This approach is reactive and potentially indiscriminate, risking system instability or incompatibility with existing configurations. It bypasses the necessary diagnostic steps and could introduce new vulnerabilities or operational issues, failing to uphold the principle of maintaining a stable and secure production environment. Ignoring the anomaly until a user reports an issue is a significant ethical and regulatory failure. This demonstrates negligence and a disregard for proactive system monitoring and maintenance. It exposes the organization to potential data loss, security breaches, and compliance violations, as it fails to meet the expected standard of care in managing critical data systems. Professional reasoning. Professionals should approach such situations by following a structured incident response plan. This typically involves 1. Detection and alerting, recognizing the anomaly. 2. Triage and diagnosis, investigating the anomaly to understand its nature, scope, and potential impact. 3. Containment, taking steps to prevent further damage or spread if the anomaly is confirmed as a threat. 4. Eradication, removing the root cause of the anomaly. 5. Recovery, restoring systems to normal operation. 6. Post-incident review, analyzing the incident to prevent recurrence. This systematic process ensures that actions are data-driven, proportionate, and aligned with regulatory and ethical obligations. Question 4. Process analysis reveals that the current DB2 one database system is nearing its end of support, posing security risks and limiting access to new features. A critical upgrade is necessary to maintain system integrity and leverage enhanced functionalities. The IT department is considering several strategies for implementing this upgrade, which approach best balances the need for modernization with the imperative to safeguard data and ensure minimal disruption to ongoing business operations. Option A. Schedule the upgrade during the busiest operational hours to minimize the overall project timeline, with a plan to address any issues as they arise. Option B. Implement the upgrade in a dedicated test environment that closely replicates the production setup, followed by a phased rollout to production after successful validation and a confirmed rollback plan. Option C. Proceed with the upgrade on the production system without notifying or involving application owners, as the database is a separate component. Option D. Conduct the upgrade directly on the production DB2 one system during a scheduled maintenance window, assuming minimal impact based on vendor documentation. The correct answer is D. Conduct the upgrade directly on the production DB2 one system during a scheduled maintenance window, assuming minimal impact based on vendor documentation. Explanation. Scenario analysis. This scenario presents a common challenge in database management where a critical system update is required, but the potential for data corruption or service disruption is high. The professional is tasked with balancing the need for modernization and security patching against the imperative to maintain data integrity and availability. The challenge lies in selecting an appropriate strategy that minimizes risk while achieving the necessary technical objectives, all within the context of established best practices and potential regulatory considerations for data handling. Even if not explicitly stated as a regulatory compliance question, in this specific exam context, pressure to deliver a timely solution without compromising the production environment necessitates careful planning and risk assessment. Correct approach analysis. The correct approach involves a phased rollout strategy, beginning with a pilot or test environment that mirrors the production setup as closely as possible. This allows for thorough testing of the DB2 one upgrade, including performance, compatibility with existing applications, and data integrity checks. If issues arise, they can be identified and resolved in a controlled environment without impacting live operations. This methodical approach aligns with principles of sound IT governance and risk management, ensuring that changes are validated before broad deployment. It demonstrates a commitment to operational stability and data protection, which are foundational to professional IT practice. Incorrect approach is analysis. Implementing the upgrade directly on the production system without prior testing is a significant regulatory and ethical failure. It demonstrates a disregard for data integrity and business continuity, potentially leading to data loss, system downtime, and financial repercussions for the organization. This approach violates the principle of due diligence and professional responsibility to safeguard organizational assets. Performing the upgrade during peak business hours without adequate rollback procedures is also professionally unacceptable. This increases the likelihood of impacting users and business operations, leading to potential service-level agreement violations and reputational damage. It shows a lack of foresight and risk mitigation planning. Attempting the upgrade without consulting application owners or end users is another failure. This neglects the critical interdependencies between the database and the applications that rely on it. Such an oversight can lead to unexpected application failures post-upgrade, causing widespread disruption and requiring extensive troubleshooting. It demonstrates a lack of collaborative practice and understanding of the broader IT ecosystem. Professional reasoning. Professionals should adopt a structured, risk-based approach to system changes. This involves 1. Understanding the business impact of the proposed change. 2. Thoroughly assessing potential risks and developing mitigation strategies. 3. Planning and executing changes in a controlled manner starting with non-production environments. 4. Ensuring comprehensive testing and validation at each stage. 5. Establishing clear rollback plans in case of unforeseen issues. 6. Communicating effectively with all stakeholders, including application owners and end users. This systematic process ensures that technical objectives are met while prioritizing data integrity, system availability, and business continuity. Question 5. The efficiency study reveals that several critical reports are taking an unacceptably long time to generate, impacting business operations. The database administrator is considering several strategies to improve performance, which approach best balances the need for speed with the imperative to maintain data integrity and comply with relevant regulations. Option A. Immediately implement aggressive indexing on all frequently queried columns to speed up report generation, without a detailed analysis of write performance or potential data conflicts. Option B. Analyze the data's access patterns and usage, identify critical tables and indexes, and then implement targeted indexing and query optimization strategies, ensuring thorough testing for data integrity and performance impact across all operations. Option C. Temporarily disable all data integrity constraints to expedite data loading and processing for the reports, planning to re-enable them later. Option D. Focus solely on optimizing the SQL queries for the reports, making significant changes to the query logic without considering the underlying data model or the impact on other system functions. Correct answer is B. Analyze the data's access patterns and usage, identify critical tables and indexes, and then implement targeted indexing and query optimization strategies, ensuring thorough testing for data integrity and performance impact across all operations. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires balancing the immediate need for system performance improvement with the long-term implications of data integrity and regulatory compliance. The pressure to deliver results quickly can lead to shortcuts that compromise fundamental database principles. Careful judgment is required to ensure that performance enhancements do not inadvertently introduce risks to data accuracy, security, or auditability, which are critical under the specified regulatory framework. Correct approach analysis. The correct approach prioritizes a thorough understanding of the data and its usage before implementing performance tuning. This aligns with best professional practice by ensuring that any changes are well-informed and do not negatively impact data integrity or violate regulatory requirements for data management. Specifically, it adheres to principles of data governance and risk management, which are implicitly or explicitly mandated by regulations governing data handling and system reliability. This approach ensures that performance tuning is a controlled process, minimizing the risk of unintended data corruption or loss, and maintaining the audit trail necessary for compliance. Incorrect approach is analysis, an approach that immediately implements aggressive indexing strategies without analyzing the data's access patterns or potential impact on right operations is professionally unacceptable. This can lead to performance degradation in other areas, increased storage overhead, and potential data inconsistencies if not managed carefully. It fails to adhere to principles of controlled change management and risk assessment, which are fundamental to maintaining system stability and data integrity. Another incorrect approach involves disabling data integrity constraints to speed up data loading or processing. This is a severe regulatory and ethical failure. Data integrity constraints are essential for ensuring the accuracy and reliability of data, which is often a legal requirement for reporting and decision-making. Violating these constraints undermines the trustworthiness of the data and can lead to significant compliance issues, fines, and reputational damage. Finally, an approach that focuses solely on query optimization without considering the underlying data model or the impact of changes on other applications or users is also professionally flawed. This narrow focus can lead to a situation where one aspect of performance is improved at the expense of others, creating new problems and potentially violating service-level agreements or operational requirements. It demonstrates a lack of holistic system understanding and a failure to consider the broader impact of technical decisions. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a comprehensive assessment of the current state, including data characteristics, workload patterns, and existing performance metrics. This should be followed by a risk assessment of potential solutions, considering their impact on data integrity, security, and compliance. Changes should be implemented incrementally, with thorough testing and validation at each stage. Continuous monitoring and performance tuning, guided by a deep understanding of the database's role within the broader business and regulatory context, are crucial for sustained efficiency and compliance. Question 6. Stakeholder feedback indicates a need for immediate access to customer transaction history for a new marketing campaign. The stakeholder has requested a direct export of the entire transaction table from the production database. Option A. Provide the stakeholder with a sample of transaction data that is not specific to any customer to avoid potential privacy issues. Option B. Consult internal data governance policies and security protocols to determine the appropriate, authorized method for data extraction and access, potentially involving a data steward or security team for approval and guidance. Option C. Inform the stakeholder that their request cannot be fulfilled due to security concerns and provide no alternative. Option D. Immediately provide the stakeholder with a direct export of the entire transaction table from the production database to meet the urgent business need. The correct answer is B. Consult internal data governance policies and security protocols to determine the appropriate, authorized method for data extraction and access, potentially involving a data steward or security team for approval and guidance. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires balancing the immediate need for data access with the long-term implications of data integrity and security. The stakeholder's request, while seemingly straightforward, touches upon fundamental principles of data management and compliance. The challenge lies in interpreting the request within the context of established data governance policies and potential regulatory requirements, ensuring that any action taken is both effective and compliant. Careful judgment is required to avoid unauthorized access or modification of sensitive data, which could lead to significant operational, legal, and reputational damage. Correct approach analysis. The correct approach involves a thorough review of existing data access policies and procedures. This aligns with best professional practice by prioritizing adherence to established governance frameworks. Specifically, it ensures that data access is granted only after proper authorization, following documented processes that are designed to maintain data integrity and security. This methodical approach is crucial for compliance with data protection regulations, which mandate controlled access and audit trails. By consulting internal policies and potentially seeking guidance from data governance or security teams, the professional demonstrates a commitment to responsible data handling and risk mitigation. Incorrect approach is analysis. One incorrect approach involves directly granting the stakeholder access to the requested data without verification. This represents a significant regulatory and ethical failure. It bypasses established security protocols, potentially exposing sensitive information to unauthorized individuals or for unintended purposes. This action could violate data privacy laws by failing to ensure data is accessed only by authorized personnel and for legitimate business reasons. It also undermines the principle of least privilege, a core security concept. Another incorrect approach is to ignore the request entirely. This is professionally unacceptable as it demonstrates a lack of responsiveness and can lead to frustration among stakeholders, hindering business operations. Ethically, it fails to uphold the professional duty to facilitate legitimate business needs while adhering to controls. From a regulatory perspective, while not a direct violation, it can indirectly lead to noncompliance if the stakeholder, unable to obtain data through proper channels, resorts to unauthorized methods. A third incorrect approach is to provide a generic, unverified dataset that might not fully meet the stakeholder's specific needs. While seemingly helpful, this can lead to inaccurate analysis or decisions by the stakeholder, impacting business outcomes. It also fails to address the root cause of the request and may necessitate further, potentially less controlled, requests later. This approach lacks the diligence required to ensure data accuracy and relevance, which is a cornerstone of responsible data management. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes understanding the request, assessing its implications against established policies and regulations, and then executing the appropriate authorized course of action. This involves 1. Clarification, fully understanding the stakeholder's need and the specific data required. 2. Policy review, consulting internal data governance, security, and access control policies. 3. Risk assessment, evaluating potential risks associated with granting access, including data privacy, security, and integrity. 4. Authorization, obtaining necessary approvals based on policy and risk assessment. 5. Controlled execution, granting access or providing data in a manner that adheres to all established controls and audit requirements. 6. Documentation, maintaining records of the request, assessment, and action taken. Question 7. The assessment process reveals that a critical application is experiencing significant delays during data retrieval operations. The database administrator suspects that the current indexing strategy might be suboptimal for the frequently executed queries. The administrator has access to DB2 one's built-in tools for analyzing query performance and database statistics. What is the most professional and effective course of action to address this performance degradation? Option A. Rewrite the application code to use different SQL statements that might be less resource-intensive, without first investigating the database's indexing and query plan. Option B. Analyze the query execution plans for the slow queries, examine the existing indexes, and consider creating new, more appropriate indexes or modifying existing ones based on the analysis of query patterns and data distribution. Option C. Immediately create new indexes on all columns that appear in the where clauses of the slow queries to ensure faster data filtering. Option D. Rely solely on DB2 Automatic Indexing Advisor to generate and implement new indexes without manual review or understanding of the underlying query logic. The correct answer is B. Analyze the query execution plans for the slow queries, examine the existing indexes, and consider creating new, more appropriate indexes or modifying existing ones based on the analysis of query patterns and data distribution. Explanation. The assessment process reveals a scenario where a database administrator is tasked with optimizing query performance in a DB2 environment. The challenge lies in balancing the need for improved performance with the potential impact on data integrity and adherence to established operational procedures. The administrator must consider the implications of modifying database structures and query logic, ensuring that any changes are well justified and do not introduce new risks. Careful judgment is required to select the most appropriate optimization strategy without compromising the system's reliability or violating best practices. The correct approach involves a systematic and data-driven method for identifying and resolving performance bottlenecks. This includes analyzing query execution plans, understanding indexing strategies, and considering the impact of statistics. By focusing on these fundamental aspects of database performance tuning, The administrator ensures that optimizations are targeted, effective, and maintain data integrity. This approach aligns with professional best practices by prioritizing a thorough understanding of the system's behavior before implementing changes. It also implicitly adheres to regulatory frameworks that mandate system stability and data accuracy by employing a controlled and analytical method. An incorrect approach would be to arbitrarily add indexes without a clear understanding of their necessity or impact. This can lead to increased storage overhead, slower write operations, and potentially no significant improvement in read performance if the indexes are not well suited to the queries. This violates professional practice by introducing changes without proper analysis, potentially degrading overall system performance and increasing maintenance complexity. It could also be seen as a failure to adhere to operational guidelines that require documented justification for system modifications. Another incorrect approach is to modify application code to circumvent perceived database inefficiencies without first investigating database-level solutions. This shifts the burden of performance to the application layer, which may not be the most efficient or scalable solution. It also creates a dependency on application changes for database performance, making troubleshooting and maintenance more complex. This approach fails to address the root cause of the performance issue within the database itself and can lead to a fragmented and difficult-to-manage system, potentially violating principles of efficient resource utilization. A third incorrect approach is to solely rely on automated tuning tools without understanding the underlying principles. While these tools can be helpful, they may not always provide the optimal solution or may introduce unintended consequences if not properly supervised. Over-reliance on automation without human oversight can lead to suboptimal configurations and a lack of deep understanding of the system's behavior, which is crucial for effective long-term management. This can be considered a failure to exercise professional due diligence and a potential breach of responsibility for system integrity. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the problem. Clearly define the performance issue and its impact. 2. Gather data. Collect relevant metrics, query logs, and execution plans. 3. Analyze data. Identify the root cause of the performance bottleneck. 4. Formulate solutions. Develop potential optimization strategies based on the analysis. 5. Evaluate solutions. Consider the impact of each solution on performance, integrity, and operational overhead. 6. Implement and test. Apply the chosen solution in a controlled environment and thoroughly test its effectiveness. 7. Monitor and refine. Continuously monitor system performance and make adjustments as needed. Question 8. Market research demonstrates that a significant portion of users are experiencing performance degradation with the current DB2 one database system. A critical update is available that promises to resolve these issues and enhance overall system efficiency. The IT department is tasked with implementing this update on the production environment. What is the most prudent approach to minimize risk to data integrity and ensure business continuity? Option A. Implement the update on a pilot group of users first, closely monitoring performance and gathering feedback before a full production rollout. Option B. Deploy the update to the production environment, but without establishing a specific rollback plan in case of unforeseen complications. Option C. Execute the update on a development server and, upon successful completion there, proceed with the production deployment without further testing. Option D. Apply the update directly to the production environment during the next scheduled maintenance window, assuming it will resolve the performance issues. The correct answer is A. Implement the update on a pilot group of users first, closely monitoring performance and gathering feedback before a full production rollout. Explanation. Scenario analysis. This scenario presents a common challenge in data management where a critical system update requires careful consideration of data integrity and availability. The professional must balance the need for system improvement with the imperative to maintain uninterrupted service and comply with data protection regulations. The challenge lies in selecting an approach that minimizes risk to data and business operations while adhering to best practices for system maintenance and data governance. Correct approach analysis. The correct approach involves a phased rollout strategy, starting with a pilot group. This represents best professional practice because it allows for real-world testing of the DB2 one update in a controlled environment by monitoring performance, identifying potential issues, and gathering feedback from a limited user base. the organization can mitigate risks before a full-scale deployment. This aligns with principles of responsible system management and risk aversion, ensuring that data remains accessible and accurate throughout the update process. It also allows for timely correction of any unforeseen problems, thereby safeguarding data integrity and business continuity. Incorrect approach is analysis. Implementing the update directly on the production environment without prior testing is a significant regulatory and ethical failure. It directly contravenes the principle of due diligence in system management, potentially leading to data corruption, service outages, and non-compliance with data availability requirements. This approach demonstrates a disregard for risk management and could result in severe business disruption and reputational damage. Performing the update during a scheduled maintenance window, but without a rollback plan, is also professionally unacceptable. While the intention might be to minimize downtime, the absence of a rollback strategy means that if the update fails or introduces critical issues, there is no immediate mechanism to revert to a stable state. This exposes the organization to prolonged downtime and potential data loss, violating the implicit ethical obligation to protect client data and ensure service reliability. Conducting the update solely on a development environment and assuming it will work flawlessly in production is insufficient. Development environments often differ significantly from production in terms of data volume, user load, and configuration. This approach fails to account for the complexities of the live production system and overlooks the potential for environment-specific issues to arise, thereby risking data integrity and operational stability in the production environment. Professional reasoning. Professionals should adopt a risk-based approach to system updates. This involves a thorough assessment of potential impacts, followed by the development of a comprehensive plan that includes testing, phased deployment, and robust rollback procedures. Prioritizing data integrity and business continuity is paramount. Decision-making should be guided by established IT governance frameworks and a commitment to minimizing disruption and safeguarding data assets. Question 9. The efficiency study reveals that a critical financial reporting query is experiencing significant performance degradation, impacting the timely generation of regulatory reports. The database administrator, DBA, has identified that altering the physical storage layout of the underlying tables could drastically improve query execution speed. However, this approach carries a risk of compromising the historical auditability of the data. What is the most appropriate course of action for the DBA to take? Option A. Investigate and implement alternative indexing strategies or query optimization techniques that do not involve altering the fundamental data storage format or compromising data integrity. Option B. Ignore the performance issue, citing the risk of data alteration, and continue with the current query performance. Option C. Directly modify the physical storage layout of the tables to achieve faster data retrieval, assuming the performance gains outweigh the potential auditability concerns. Option D. Denormalize the database schema significantly to speed up reads, without a comprehensive assessment of the long-term implications for data consistency. The correct answer is A. Investigate and implement alternative indexing strategies or query optimization techniques that do not involve altering the fundamental data storage format or compromising data integrity. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the need to balance performance optimization with data integrity and regulatory compliance. The database administrator, DBA, is tasked with improving query performance, a common and expected duty. However, the proposed method involves altering data storage structures in a way that could impact data consistency and auditability, which are critical for regulatory adherence. The challenge lies in identifying a solution that meets performance goals without compromising the integrity and compliance requirements mandated by the relevant regulatory framework for financial data. Careful judgment is required to assess the risks associated with each potential solution. Correct approach analysis. The correct approach involves investigating and implementing alternative indexing strategies or query optimization techniques that do not involve altering the fundamental data storage format or potentially compromising data integrity. This aligns with best professional practice because it prioritizes data accuracy and compliance. Specifically, in a regulated environment like financial services, maintaining accurate and auditable data is paramount. Regulatory bodies often have strict guidelines regarding data retention, integrity, and the ability to reconstruct transactions. Employing standard, well-documented database tuning methods, such as creating appropriate indexes, rewriting inefficient queries, or utilizing database-specific performance tuning tools, ensures that data remains consistent and that any changes are traceable and compliant with established data governance policies. This approach demonstrates a commitment to responsible data management and adherence to the principles of data integrity and security, which are often implicitly or explicitly required by financial regulations. Incorrect approaches analysis. One incorrect approach involves directly modifying the physical storage layout of the tables to achieve faster data retrieval, without thoroughly assessing the impact on data consistency or the ability to perform historical audits. This is professionally unacceptable because it bypasses established procedures for data modification and potentially violates regulatory requirements for data integrity and auditability. Financial regulations often mandate that data be immutable or at least have a clear audit trail of any modifications. Altering physical storage could inadvertently corrupt data, make it difficult to reconstruct past states, or obscure the history of changes, all of which are significant regulatory failures. Another incorrect approach is to ignore the performance issue entirely, citing the risk of data alteration. While caution is important, outright inaction is not a professional solution. It fails to meet the implicit or explicit requirement to maintain an efficient and responsive system, which can indirectly impact business operations and, in some regulated contexts, the ability to meet reporting deadlines. This approach demonstrates a lack of proactive problem-solving and a failure to explore compliant solutions. A third incorrect approach is to implement a quick fix that involves denormalizing the database schema significantly to speed up reads, without considering the long-term implications for data redundancy, update anomalies, and the complexity of maintaining data consistency across multiple redundant copies. While denormalization can improve read performance, it introduces significant risks to data integrity, making it harder to ensure that all copies of the data are synchronized and accurate. This can lead to reporting errors and regulatory breaches, as the data may not accurately reflect the true state of financial transactions. Professional reasoning. Professionals in this situation should employ a structured decision-making process. First, clearly define the performance problem and its impact. Second, research and identify potential solutions, prioritizing those that maintain data integrity and compliance. This involves consulting database documentation, performance tuning guides, and any relevant internal policies or regulatory guidelines. Third, conduct a thorough risk assessment for each viable solution, evaluating its potential impact on data accuracy, auditability, security, and compliance. Fourth, implement the chosen solution in a controlled environment, e.g., a test or staging environment, and rigorously test its performance and integrity before deploying to production. Finally, document all changes, the rationale behind them, and the testing performed, ensuring a clear audit trail for future reference and regulatory review. This systematic approach ensures that performance goals are met responsibly and ethically within the bounds of regulatory requirements. Question 10. Benchmark analysis indicates that a company's reporting team requires access to customer data stored in a DB2 one database for market trend analysis. This data includes personally identifiable information (PI) in several columns. The company operates under strict data protection regulations that mandate the protection of PII. Which of the following approaches best balances the reporting team's need for data with the organization's regulatory obligations? Option A. Exclude all columns that might contain sensitive data from the extraction, even if they are crucial for meaningful analysis. Option B. Provide the reporting team with direct access to the production database, including all sensitive columns, with a verbal instruction to be careful. Option C. Implement data masking techniques on sensitive columns before extracting the data for the reporting team. Option D. Assume that because the data is stored within a DB2 database, it is inherently secure and does not require additional masking for reporting purposes. The correct answer is C. Implement data masking techniques on sensitive columns before extracting the data for the reporting team. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and regulatory compliance within the context of DB2 1. Database management. The core difficulty lies in balancing the need for data analysis and reporting with the stringent requirements of data protection regulations. Organizations must ensure that sensitive personal data is handled appropriately, even when accessed for legitimate business purposes. This requires a thorough understanding of the data, the applicable regulations, and the technical capabilities of the database system to implement effective controls. The pressure to deliver timely insights can sometimes lead to shortcuts that inadvertently violate compliance mandates, making careful judgment and a proactive approach essential. Correct approach analysis. The correct approach involves implementing data masking techniques on sensitive columns before extracting data for the reporting team. This aligns with the principles of data minimization and purpose limitation, fundamental to many data protection regulations. By masking sensitive data, the organization reduces the risk of unauthorized disclosure or misuse, even if the extracted data is accessed by individuals who do not have a legitimate need to see the raw sensitive information. This proactive measure ensures that the reporting team can perform their analysis without compromising the privacy of individuals whose data is contained within the database. It demonstrates a commitment to regulatory compliance and ethical data handling, safeguarding both the organization and its customers. Incorrect approach is analysis. One incorrect approach is to provide the reporting team with direct access to the production database, including all sensitive columns, with a verbal instruction to be careful. This is a significant regulatory and ethical failure. It violates the principle of least privilege, granting access beyond what is necessary for the reporting function. It also fails to implement technical controls to enforce data protection, relying solely on human discretion, which is inherently fallible. This approach significantly increases the risk of data breaches and noncompliance with data protection laws, which mandate appropriate technical and organizational measures to protect personal data. Another incorrect approach is to exclude all columns that might contain sensitive data from the extraction, even if they are crucial for meaningful analysis. While this prioritizes data protection by omission, it is professionally unacceptable because it hinders the legitimate business purpose of the reporting team. Regulations often require organizations to process data for specified, explicit, and legitimate purposes. Simply removing all potentially sensitive data renders the data useless for its intended purpose, failing to meet the organization's operational needs and potentially leading to incomplete or inaccurate business decisions. This approach demonstrates a lack of understanding of how to balance data protection with operational requirements. A third incorrect approach is to assume that because the data is stored within a DB2 database, it is inherently secure and does not require additional masking for reporting purposes. This is a dangerous assumption and a clear regulatory failure. Database security, while important, does not automatically equate to compliance with data privacy regulations concerning the *use* and *access* of personal data for specific purposes. Regulations often require specific controls around the processing of personal data, even within a secure environment, to prevent unauthorized access or disclosure for purposes beyond the original collection. Professional reasoning. Professionals should adopt a risk-based approach to data handling. This involves identifying sensitive data, understanding the applicable regulatory framework e.g., GDPR, CCPA, or other relevant jurisdiction-specific laws, and assessing the risks associated with different data processing activities. When data is extracted for reporting or analytical purposes, the primary consideration should be to fulfill the business need, while minimizing the exposure of sensitive personal data. This often involves employing technical controls such as data masking, anonymization, or pseudonymization. Professionals should consult with legal and compliance teams to ensure their chosen methods meet all regulatory requirements. Documentation of the implemented controls and the rationale behind them is also crucial for demonstrating due diligence and compliance. Question 11. Assessment of the most appropriate immediate action for a DB2 database administrator when encountering unexpected data corruption, considering the need for regulatory compliance and data integrity. Option A. Analyze DB2 audit logs to determine the sequence of events leading to the corruption before proceeding with recovery. Option B. Immediately attempt manual correction of the corrupted data based on educated guesses. Option C. Initiate a full database restore from the most recent valid backup without further investigation. Option D. Proceed with normal database operations, disregarding the data corruption. The correct answer is C. Initiate a full database restore from the most recent valid backup without further investigation. Explanation: scenario analysis. This scenario presents a professional challenge because it requires a database administrator to balance the immediate need for data access with the long-term implications of data integrity and regulatory compliance. The pressure to restore service quickly can lead to shortcuts that violate established procedures and potentially compromise sensitive information. Careful judgment is required to ensure that any recovery process adheres to the principles of data security and auditability mandated by regulatory frameworks. Correct approach analysis. The correct approach involves a thorough review of the DB2 audit logs to identify the exact sequence of events leading to the data corruption. This aligns with best professional practice because it provides an auditable trail of actions, essential for regulatory compliance and for understanding the root cause of the issue. By meticulously examining the logs, the administrator can determine if unauthorized access or configuration errors occurred, which is crucial for preventing recurrence and for reporting to relevant authorities if required by regulations. This methodical approach ensures that the recovery process is not only effective, but also defensible from a compliance standpoint. Incorrect approaches analysis. One incorrect approach involves immediately restoring the database from the most recent backup without investigating the cause of the corruption. This is professionally unacceptable because it bypasses the critical step of understanding the failure, potentially leaving vulnerabilities unaddressed. From a regulatory perspective, this could be seen as a failure to implement adequate data governance and incident response procedures. If the corruption was due to a security breach, failing to investigate could violate data protection regulations by not identifying and mitigating the threat. Another incorrect approach is to attempt to manually correct the corrupted data based on assumptions about its original state. This is highly risky and professionally unsound. It introduces a high probability of further data inconsistencies and errors, undermining data integrity. Regulatory frameworks often require that data be accurate and reliable. Manual, undocumented corrections can lead to non-compliance with these requirements. Furthermore, such actions would likely not be reflected in audit logs, making it impossible to reconstruct the recovery process for audit purposes. A third incorrect approach is to ignore the corruption and continue operating the database, hoping the issue resolves itself or becomes irrelevant. This is a severe dereliction of duty and a direct violation of professional standards and regulatory expectations for data management. Data integrity is paramount, and ignoring corruption can lead to incorrect business decisions, financial losses, and significant legal and regulatory penalties. It demonstrates a complete disregard for data governance principles and the organization's responsibility to maintain accurate records. Professional reasoning. Professionals should approach such situations by first prioritizing data integrity and regulatory compliance. This involves a structured incident response plan that includes immediate containment, thorough investigation using available audit trails, and a documented recovery process. The decision-making process should always favor methods that are auditable, repeatable, and demonstrably compliant with relevant regulations. When in doubt, consulting with security and compliance officers is a crucial step to ensure that all actions meet the required standards. Question 12. Comparative studies suggest that organizations often struggle with the nuanced application of data privacy regulations when managing large datasets within database systems. Considering the regulatory framework applicable to data protection and privacy, which of the following approaches best aligns with ensuring compliance while enabling necessary data analysis within a DB2 environment? Option A. Relying solely on network-level security measures to protect the database, assuming that internal data access will not pose a privacy risk. Option B. Implementing granular access controls and encryption for sensitive data fields, coupled with a clear data retention policy that aligns with regulatory requirements for personal data. Option C. Extracting all data from the DB2 database into a separate, less secure environment for analysis to simplify the process and avoid complex database configurations. Option D. Conducting data analysis on the production DB2 database without any specific measures to identify or protect potentially sensitive personal information within the datasets. The correct answer is B. Implementing granular access controls and encryption for sensitive data fields, coupled with a clear data retention policy that aligns with regulatory requirements for personal data. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and regulatory compliance within the context of DB2 One database management. The core difficulty lies in balancing the need for data analysis and reporting with the stringent requirements of data protection regulations. Misinterpreting or misapplying these regulations can lead to significant legal penalties, reputational damage, and loss of customer trust. The professional must exercise careful judgment to ensure that data handling practices are both effective for business needs and fully compliant with the law. Correct approach analysis. The correct approach involves a thorough understanding of the applicable data protection regulations, such as those governing personal data handling and privacy. This includes identifying what constitutes personal data, understanding the legal basis for processing such data, e.g., consent, legitimate interest, and implementing appropriate technical and organizational measures to safeguard it. Specifically for DB2 1. This would translate to utilizing its built-in security features, access controls, encryption capabilities, and auditing mechanisms to protect sensitive information. Adhering to principles like data minimization, purpose limitation, and ensuring data accuracy are paramount. This approach represents best professional practice because it directly addresses the legal and ethical obligations to protect individuals' privacy while enabling legitimate data utilization. It demonstrates a proactive commitment to compliance, minimizing risk and fostering a trustworthy environment. Incorrect approach is analysis. An incorrect approach would be to proceed with data extraction and analysis without a clear understanding of the data's sensitivity or the relevant regulatory framework. This could involve assuming all data is non-personal or that existing security measures are sufficient without verification. Such an approach fails to acknowledge the legal obligations to protect personal data, potentially leading to unauthorized access, disclosure, or misuse. This constitutes a significant regulatory failure, as it violates principles of data protection and privacy. Another incorrect approach would be to implement overly restrictive data access policies that hinder legitimate business operations, even if the intention is to be cautious. While security is important, an approach that makes data unusable for necessary reporting or analysis without a clear regulatory basis for such restriction is inefficient and can be detrimental to business objectives. This might stem from a misunderstanding of the scope of regulations or an overzealous interpretation. A third incorrect approach would be to rely solely on generic security best practices without considering the specific requirements of data protection laws. While general security is a foundation, it does not automatically guarantee compliance with specific privacy mandates. For instance, a system might be secure from external breaches, but still violate privacy regulations if data is processed or shared inappropriately internally. This represents a failure to align technical security with legal and ethical privacy obligations. Professional reasoning. Professionals facing such situations should adopt a structured decision-making process. First, identify the nature of the data being handled and determine if it falls under any data protection regulations. Second, consult the specific regulatory framework applicable to the jurisdiction and the type of data. Third, assess the existing data management and security practices within DB2 against these regulatory requirements. Fourth, implement necessary controls, such as encryption, access restrictions, and auditing, to ensure compliance. Fifth, document all decisions and actions taken to demonstrate due diligence. Continuous monitoring and periodic review of compliance measures are also essential. This systematic approach ensures that data handling is both legally sound and operationally effective. Question 13. Process analysis reveals a critical security vulnerability in the DB2 database system that requires an immediate patch. The organization's primary customer-facing application relies heavily on this database, and any downtime or data corruption would have severe financial and reputational consequences. Given the urgency, which of the following approaches best balances the need for rapid remediation with the imperative to maintain data integrity and system availability, adhering to regulatory expectations for critical system changes? Option A. Conduct a comprehensive testing of the patch in a staging environment that precisely mirrors the production setup, followed by a phased rollout to production servers with continuous monitoring and a defined rollback strategy. Option B. Apply the patch to a small subset of production servers first to gauge its impact, then proceed with the remaining servers if no immediate issues are observed. Option C. Implement the patch immediately in the production environment without extensive testing, prioritizing speed of remediation over potential, albeit unlikely, data integrity issues. Option D. Deploy the patch directly to the production DB2 environment during a scheduled maintenance window, ensuring a rollback plan is in place. The correct answer is D. Deploy the patch directly to the production DB2 environment during a scheduled maintenance window, ensuring a rollback plan is in place. Explanation. Scenario analysis. This scenario presents a common challenge in database management where a critical system update is required, but the potential for data corruption or service disruption is high. The professional is tasked with balancing the need for modernization and security patches against the imperative to maintain data integrity and availability. The challenge lies in selecting a method that minimizes risk while achieving the necessary technical objectives, all within the context of strict regulatory compliance for data handling and system operations. The pressure to act quickly due to security vulnerabilities adds another layer of complexity, demanding a well-reasoned and defensible decision. Correct approach analysis. The correct approach involves a phased rollout with comprehensive testing in a non-production environment that mirrors the production system as closely as possible. This aligns with best practices for database upgrades and is implicitly supported by regulatory frameworks that mandate data integrity and system resilience. Specifically, regulations often require that changes to critical systems be thoroughly vetted to prevent adverse impacts on data accuracy, completeness, and availability. A staged deployment allows for early detection of issues, rollback capabilities, and minimizes the blast radius of any unforeseen problems. This methodical approach demonstrates due diligence and a commitment to safeguarding data, which is a fundamental ethical and regulatory obligation. Incorrect approach is analysis. Implementing the update directly in the production environment without prior testing is a severe regulatory and ethical failure. This bypasses essential risk mitigation steps, directly violating principles of data integrity and system availability that are foundational to most data protection and financial regulations. It exposes the organization to significant risks of data loss, corruption, or extended downtime, which could lead to financial penalties, reputational damage, and loss of customer trust. Performing the update during peak business hours without a rollback plan is also professionally unacceptable. The intention might be to minimize disruption to non-critical operations. It ignores the potential for catastrophic failure during a high-demand period. The absence of a rollback plan means that if an issue arises, the system could be rendered inoperable for an extended duration, directly contravening requirements for business continuity and data accessibility. This demonstrates a lack of foresight and a disregard for the potential consequences of a failed deployment. Applying the update only to a subset of the production servers without a clear strategy for the remaining servers is equally problematic. This creates an inconsistent environment, potentially leading to data synchronization issues, application errors, and security vulnerabilities across different parts of the system. It fails to ensure the integrity and uniformity of the database as a whole, which is a core regulatory expectation for data management. Professional reasoning. Professionals facing such a decision should employ a risk-based approach. This involves identifying potential risks associated with each deployment strategy, assessing their likelihood and impact, and then selecting the strategy that best mitigates these risks while achieving the desired outcome. A critical component of this process is thorough documentation of the decision-making rationale, including the testing performed, risk assessment, and contingency plans. Consulting with relevant stakeholders, including IT security, operations, and business units, is also crucial to ensure all perspectives are considered. Adherence to established change management procedures, which typically mandate testing and rollback plans for critical system updates, is paramount. Question 14. To address the challenge of safeguarding sensitive customer financial data within DB2 against unauthorized internal access and potential misuse, which of the following strategies best aligns with regulatory compliance and professional best practices for data protection? Option A. disabling all auditing features in DB2 one to reduce system overhead and potential performance impacts. Option B, granting all employees within the finance department broad read and write access to all customer financial records to facilitate efficient data analysis. Option C, implementing a system of granular user privileges, role-based access control, and comprehensive audit logging to track all data access and modifications. Option D, relying primarily on perimeter network security measures to prevent external access, assuming internal users will act appropriately. The correct answer is C, implementing a system of granular user privileges, role-based access control, and comprehensive audit logging to track all data access and modifications. Explanation: scenario analysis. This scenario presents a professional challenge related to data privacy and security within a financial institution, specifically concerning the handling of sensitive customer information in DB2 1. The core difficulty lies in balancing the need for data accessibility for legitimate business operations with the imperative to protect customer data from unauthorized access or disclosure, as mandated by regulatory frameworks. The complexity arises from the potential for internal misuse of data, even by authorized personnel, and the need for robust controls that are both effective and practical to implement and maintain. Careful judgment is required to ensure that all data handling practices comply with the relevant regulations, maintain customer trust, and mitigate the risk of significant financial and reputational damage. Correct approach analysis. The correct approach involves implementing granular access controls and robust auditing mechanisms within DB2 1. This aligns with the principles of least privilege, ensuring that users and applications only have access to the data they absolutely need to perform their designated functions. Furthermore, comprehensive auditing provides a transparent record of data access and modifications, which is crucial for detecting and investigating any potential breaches or misuse. This proactive and layered security strategy is best professional practice because it directly addresses the regulatory requirements for data protection and integrity, such as those found in data privacy laws that mandate secure processing and accountability. It demonstrates a commitment to safeguarding sensitive information and adhering to the spirit and letter of the law. Incorrect approaches analysis. Relying solely on network-level security without specific database controls is a significant regulatory and ethical failure. Network security is important. It does not provide the granular protection needed at the database level. Sensitive data can still be accessed by authorized database users who may not have a legitimate business need for it, leading to potential privacy violations and non-compliance with data protection regulations. Granting broad access privileges to all users based on their department or role without individual assessment of need represents a failure to implement the principle of least privilege. This increases the attack surface and the likelihood of accidental or intentional data misuse, directly contravening regulatory mandates for data security and accountability. Ignoring the need for regular security audits and log reviews is another critical failure. Without these mechanisms, it becomes impossible to detect unauthorized access or suspicious activity in a timely manner. This lack of oversight makes the institution vulnerable to data breaches and hinders its ability to respond effectively to incidents, thereby failing to meet regulatory expectations for ongoing monitoring and incident response. Professional reasoning. Professionals should adopt a risk-based approach to data security. This involves identifying sensitive data, understanding the regulatory requirements applicable to that data, assessing potential threats and vulnerabilities, and implementing appropriate controls. The decision-making process should prioritize controls that offer the most effective protection against the highest risks, while also considering operational efficiency. Regular review and adaptation of security measures are essential to stay ahead of evolving threats and regulatory changes. Consulting with compliance officers and legal counsel is also a vital step to ensure all practices are fully compliant. Question 15. The monitoring system demonstrates an unusual pattern in DB2 one audit log activity, specifically a series of repeated failed login attempts from an unrecognized IP address, occurring outside of typical business hours. This pattern has appeared only once before in the last 6 months. Which of the following actions best aligns with regulatory compliance requirement for managing potential security incidents related to database access? Option A. Immediately block the unrecognized IP address at the network firewall and initiate a full security audit of the DB2 instance. Option B. Investigate the source and nature of the failed login attempts, cross-reference with known authorized access patterns, and consult internal security incident response policies before taking further action. Option C. Notify all database users of a potential security breach and instruct them to change their passwords immediately. Option D. Log the event for review during the next scheduled system maintenance cycle and continue normal operations. The correct answer is A. Immediately block the unrecognized IP address at the network firewall and initiate a full security audit of the DB2 instance. Explanation: this scenario presents a professional challenge because it requires a nuanced understanding of how to interpret and act upon data generated by a monitoring system, specifically in relation to regulatory compliance for DB210. 1. The challenge lies in distinguishing between routine operational fluctuations and potential breaches of regulatory requirements without overreacting or underreacting. Careful judgment is needed to ensure that actions taken are proportionate, effective, and in line with the specified regulatory framework for the C2090-610 exam. The correct approach represents best professional practice because it prioritizes a systematic and evidence-based response, by first verifying the anomaly and then consulting the relevant regulatory documentation and internal policies. The professional ensures that any subsequent actions are grounded in fact and compliance. This methodical process minimizes the risk of false positives leading to unnecessary disruptions or, conversely, overlooking a genuine compliance issue. Adhering to established procedures for incident reporting and escalation, as dictated by the regulatory framework, is paramount for maintaining accountability and ensuring timely resolution. An incorrect approach that focuses solely on immediate system adjustments without verification risks misinterpreting normal operational variations as critical failures. This could lead to unnecessary downtime, impacting business operations and potentially violating service-level agreements, which may have their own regulatory implications. Another incorrect approach, which involves ignoring the alert due to its perceived infrequency, represents a significant regulatory and ethical failure. This demonstrates a disregard for the monitoring system's purpose and a potential violation of due diligence requirements. Overlooking a genuine anomaly could lead to a breach of data security, privacy, or integrity regulations, resulting in severe penalties. A third incorrect approach, which involves escalating the issue without any initial investigation, wastes valuable resources and can create unnecessary alarm within the organization. It fails to demonstrate a competent and efficient approach to problem-solving and compliance management. Professionals should employ a decision-making framework that begins with understanding the purpose and limitations of monitoring systems. When an alert is triggered, the first step should always be verification and context gathering. This involves cross-referencing the alert with other system logs, operational data, and known maintenance schedules. Subsequently, the professional must consult the specific regulatory requirements and internal policies applicable to the situation. If a genuine anomaly is confirmed and it pertains to a regulatory concern, a structured incident response plan should be initiated, involving appropriate stakeholders and documented thoroughly. This process ensures that actions are not only technically sound, but also legally and ethically defensible. Question 16. Risk assessment procedures indicate that a new DB210 database is being deployed to store sensitive customer financial data. Which of the following approaches would best ensure a comprehensive and effective risk assessment for this deployment? Option A. Applying a generic, off-the-shelf risk assessment template that covers common database vulnerabilities without specific consideration for DB210 features or the financial data context. Option B. Developing a tailored risk assessment framework that considers the specific architecture of the DB210 database, the nature of the financial data, and potential threat vectors relevant to financial institutions, followed by a detailed analysis of identified risks and proposed mitigation strategies. Option C. Prioritizing the completion of the risk assessment within the shortest possible timeframe by limiting stakeholder interviews and detailed vulnerability scanning. Option D. Focusing the risk assessment solely on the most common and easily identifiable database security risks, such as weak passwords, and deferring the assessment of less frequent but potentially severe risks. Correct answer is B. Developing a tailored risk assessment framework that considers the specific architecture of the DB2 one database, the nature of the financial data, and potential threat vectors relevant to financial institutions, followed by a detailed analysis of identified risks and proposed mitigation strategies. Explanation. This scenario presents a professional challenge because it requires balancing the need for robust risk assessment with the practical constraints of resource allocation and the potential for over-reliance on historical data without considering evolving threats. The core difficulty lies in determining the appropriate level of detail and the most effective methodology for assessing risks associated with a new database deployment, especially when faced with limited time and budget. Careful judgment is required to ensure that the assessment is both comprehensive enough to identify significant vulnerabilities and efficient enough to be completed within project timelines. The correct approach represents best professional practice because it involves a proactive and systematic identification of potential threats and vulnerabilities specific to the new DB2 environment. This includes considering the data sensitivity, access controls, and potential impact of breaches. By engaging relevant stakeholders, such as security personnel and database administrators, the assessment ensures that diverse perspectives are incorporated, leading to a more accurate and actionable risk profile. This aligns with the fundamental principles of information security risk management, which emphasize understanding the context, identifying risks, analyzing them, and planning for mitigation. Regulatory frameworks, while not explicitly detailed here due to the exam's focus on fundamentals, generally mandate that organizations implement appropriate security measures based on a thorough understanding of their risks. This approach demonstrates due diligence and a commitment to protecting sensitive information. An incorrect approach that relies solely on generic risk templates without tailoring them to the specific DB2 environment fails to address unique vulnerabilities. This could lead to overlooking critical risks specific to the database's configuration, data types, or intended use, potentially violating ethical obligations to protect data and regulatory requirements for adequate security. Another incorrect approach, focusing only on the most obvious or frequently occurring risks, ignores less common but potentially high-impact threats. This can result in a false sense of security and leave the organization exposed to unforeseen dangers, which is professionally negligent. Finally, an approach that prioritizes speed over thoroughness, skipping key steps like stakeholder consultation or detailed vulnerability analysis, is fundamentally flawed. This haste can lead to incomplete risk identification and inadequate mitigation strategies, exposing the organization to unacceptable levels of risk and potentially violating professional standards of care. The professional decision-making process for similar situations should involve a phased approach to risk assessment. First, clearly define the scope and objectives of the assessment, considering the specific technology, DB2 and the data it will handle. Second, identify potential threats and vulnerabilities through a combination of established methodologies and context-specific analysis. Third, analyze the likelihood and impact of identified risks. Fourth, evaluate existing controls and determine the need for new or enhanced mitigation strategies. Throughout this process, continuous communication with stakeholders and a commitment to thoroughness, even under time pressure, are paramount. Professionals must exercise critical thinking to avoid shortcuts that compromise the integrity of the assessment. Question 17. Process analysis reveals that a development team requires access to a production DB2 database to test new application features. The database contains sensitive customer information. What is the most appropriate approach to manage this access request, considering the need for both security and operational efficiency? Option A. Deny all access to production data for development testing, requiring the team to use synthetic data which may not accurately reflect production scenarios. Option B. Rely on the team lead's assurance that developers will only access necessary data and will not misuse their privileges without implementing formal controls. Option C. Conduct a formal risk assessment to identify potential threats and vulnerabilities associated with granting access, and implement controls such as data masking, role-based access, and comprehensive auditing based on the assessment findings. Option D. Grant broad read and write access to all production database objects for all members of the development team to ensure they have the necessary resources for testing. Correct answer is C. Conduct a formal risk assessment to identify potential threats and vulnerabilities associated with granting access, and implement controls such as data masking, role-based access, and comprehensive auditing based on the assessment findings. Explanation: this scenario presents a professional challenge because the database administrator must balance the need for robust security controls with the operational requirements of the development team. Implementing overly restrictive access controls can hinder productivity and delay critical development cycles, while insufficient controls expose sensitive data to unacceptable risks. The core of the challenge lies in defining and implementing a risk-based approach that aligns security measures with the actual threat landscape and business impact, rather than applying a one-size-fits-all policy. The correct approach represents best professional practice because it prioritizes a systematic and documented process for identifying, assessing, and mitigating risks. This aligns with fundamental principles of information security and data governance, which mandate that security measures be proportionate to the identified risks. By conducting a thorough risk assessment, the administrator can make informed decisions about access levels, data masking, and auditing requirements, ensuring that resources are allocated effectively to protect the most critical assets. This proactive and evidence-based methodology is crucial for demonstrating due diligence and compliance with any applicable data protection regulations, even if not explicitly stated in the exam's jurisdiction, as it reflects universally accepted security best practices. An incorrect approach that involves immediately granting broad access to all development team members without a risk assessment is professionally unacceptable. This failure constitutes a significant ethical lapse and a potential regulatory violation by disregarding the principle of least privilege and failing to implement adequate safeguards. It exposes sensitive data to unauthorized access, modification, or deletion, increasing the likelihood of data breaches and associated reputational and financial damage. Another incorrect approach, which is to deny all access to production data for development purposes, is also professionally unsound. While it prioritizes security, it fails to acknowledge the legitimate business need for realistic testing environments. This can lead to the deployment of untested code, increasing the risk of production incidents and system instability, thereby undermining the overall business objectives. It demonstrates a lack of understanding of the interplay between security and operational needs. Finally, an approach that relies solely on anecdotal evidence or the perceived trustworthiness of individual developers without a formal risk assessment is a critical failure. This subjective approach lacks objectivity and is prone to bias, failing to account for unforeseen vulnerabilities or malicious intent. It bypasses established security protocols and leaves the organization exposed to risks that could have been identified and mitigated through a structured process. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with identifying the assets and the potential threats and vulnerabilities. Next, the likelihood and impact of these threats are assessed to determine the overall risk level. Based on this assessment, appropriate controls are designed and implemented, followed by ongoing monitoring and review. This iterative process ensures that security measures remain effective and aligned with the evolving risk landscape and business requirements. Question 18. Consider a scenario where a financial institution is reviewing its data handling practices for customer account information. The institution has a vast amount of data, ranging from basic contact details to highly sensitive financial transaction histories and social security numbers. The IT department proposes a new system that promises significantly faster data retrieval and processing, but the security implications for the various data types have not been thoroughly analyzed beyond standard encryption. What is the most appropriate risk assessment approach in this situation? Option A. Rely solely on the vendor's security certifications for the new system, assuming their expertise guarantees adequate protection for all data types handled. Option B. Conduct a detailed data classification exercise to categorize customer information based on sensitivity and regulatory requirements. Then perform a risk assessment for each category to determine appropriate security controls, prioritizing the protection of the most sensitive data. Option C. Apply a uniform, high level of security controls across all customer data, regardless of its sensitivity, to ensure maximum protection and simplify management. Option D. Implement the new system immediately to leverage its performance benefits, assuming that standard encryption is sufficient for all customer data and that the risk of a breach is negligible. The correct answer is B. Conduct a detailed data classification exercise to categorize customer information based on sensitivity and regulatory requirements. Then perform a risk assessment for each category to determine appropriate security controls, prioritizing the protection of the most sensitive data. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires balancing the need for efficient data processing with the imperative to protect sensitive customer information. The core tension lies in determining the appropriate level of risk mitigation without unduly hindering business operations. A thorough risk assessment is crucial to identify potential vulnerabilities and their impact, ensuring that decisions are data-driven and aligned with regulatory expectations. Correct approach analysis. The correct approach involves a systematic and documented process of identifying, analyzing, and evaluating risks associated with handling sensitive customer data. This aligns with fundamental principles of data protection and regulatory compliance. By categorizing data sensitivity and implementing controls commensurate with the identified risks, an organization demonstrates due diligence and a commitment to safeguarding customer privacy. This proactive stance is essential for meeting the obligations imposed by data protection frameworks, which mandate risk-based approaches to data security. Incorrect approaches analysis. One incorrect approach would be to implement a blanket, one-size-fits-all security policy without considering the varying levels of sensitivity across different data types. This fails to acknowledge that not all data carries the same risk, leading to either overprotection, hindering usability, or underprotection, creating vulnerabilities. This approach is ethically questionable as it may not adequately protect the most sensitive information and is regulatorily unsound as it doesn't demonstrate a tailored risk-based strategy. Another incorrect approach would be to prioritize speed and ease of access over security, assuming that data breaches are unlikely or that the impact would be minimal. This demonstrates a disregard for the potential harm to individuals and the organization, including reputational damage and regulatory penalties. Ethically, this is a failure to uphold a duty of care to customers. Regulatorily, it directly contravenes the principles of data minimization and security by design, which are cornerstones of modern data protection laws. Third incorrect approach would be to rely solely on vendor-provided security solutions without conducting an independent assessment of their suitability for the specific data being handled. While vendors offer valuable tools, the responsibility for risk assessment and mitigation ultimately rests with the organization. This approach abdicates responsibility and may lead to overlooking unique organizational risks or misconfigurations that could expose sensitive data. It is a failure in due diligence and a potential regulatory pitfall. Professional reasoning. Professionals should approach risk assessment by first understanding the data landscape, what data is collected, where it resides, and how it is processed. This understanding should then inform a structured risk identification process, considering threats e.g., unauthorized access, data loss, and vulnerabilities e.g., weak access controls, unpatched systems. The impact of these risks on individuals and the organization must be evaluated. Based on this analysis, appropriate controls should be selected and implemented, with a clear rationale for their selection tied to the identified risks. Regular review and updates to the risk assessment are critical to adapt to evolving threats and business processes. This systematic, documented, and iterative approach ensures compliance and fosters a culture of security. Question 19. The investigation demonstrates that a critical DB2 database is experiencing significant performance degradation, impacting application responsiveness. The database administrator is under pressure to restore normal operations immediately, which approach best balances immediate needs with long-term system health and security. Option A. Conduct a thorough root cause analysis of the performance issues, assessing potential security implications and developing a targeted solution based on the findings. Option B. Temporarily disable non-essential database features to improve perceived performance while deferring a full investigation. Option C. Implement immediate hardware upgrades without a detailed analysis of the software or configuration causing the slowdown. Option D. Apply a widely used, generic performance tuning script to the database as a quick fix to restore responsiveness. The correct answer is A. Conduct a thorough root cause analysis of the performance issues, assessing potential security implications, and developing a targeted solution based on the findings. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires the database administrator to balance the immediate need for system availability with the long-term implications of security vulnerabilities. The pressure to restore service quickly can lead to shortcuts that compromise data integrity or security, potentially violating regulatory compliance and exposing the organization to significant risks. Careful judgment is required to ensure that the chosen solution is both effective in the short term and sustainable in the long term, adhering to established security protocols and best practices. Correct approach analysis. The correct approach involves a thorough risk assessment that prioritizes identifying the root cause of the performance degradation. This aligns with best professional practice by ensuring that the solution addresses the underlying issue rather than just masking symptoms. From a regulatory perspective, a systematic risk assessment is often mandated or implied by data protection regulations, e.g., GDPR, CCPA, depending on the jurisdiction relevant to the exam, which for C2090-610 DB2 1 fundamentals is assumed to be U.S.-centric, unless otherwise specified. These regulations require organizations to implement appropriate technical and organizational measures to ensure data security and integrity. A proper risk assessment is a foundational element of such measures, allowing for informed decision-making that minimizes potential harm and ensures compliance with data protection principles. Incorrect approaches analysis. Implementing a quick fix without understanding the root cause is professionally unacceptable because it fails to address the underlying problem, potentially leading to recurring issues and a false sense of security. This approach can also introduce new vulnerabilities or exacerbate existing ones, violating the principle of due diligence in data security. Ethically, it demonstrates a lack of commitment to robust system management and data protection. Ignoring the performance issue and focusing solely on other tasks is professionally negligent. It disregards the potential impact on business operations and data accessibility, which can have severe financial and reputational consequences. From a regulatory standpoint, failing to address performance issues that could lead to data unavailability or corruption can be seen as a failure to maintain adequate security and operational controls. Applying a generic performance tuning script without specific analysis is problematic because it assumes a one-size-fits-all solution, which is rarely the case in complex database environments. This can lead to unintended consequences, such as misconfiguration or the introduction of new performance bottlenecks, thereby failing to meet the standard of care expected in system administration. It bypasses the critical step of understanding the specific context and risks associated with the current system state. Professional reasoning. Professionals should adopt a structured approach to problem solving, starting with a comprehensive assessment of the situation. This involves gathering information, identifying potential causes, evaluating risks, and then developing and implementing solutions. When dealing with critical systems like databases, a risk-based approach ensures that decisions are informed, proportionate, and aligned with both business objectives and regulatory requirements. This systematic process allows for the identification of the most effective and secure resolution, minimizing the likelihood of negative outcomes. Question 20. Upon reviewing the access control configurations for a sensitive customer database managed by DB2 1. A database administrator notices that several user groups have been granted extensive privileges, including the ability to view and modify all records. The administrator is concerned about potential data breaches and unauthorized modifications. Which of the following approaches best addresses this situation while adhering to sound data security principles and regulatory expectations? Option A. Conduct a comprehensive risk assessment to identify critical data elements, evaluate potential threats and vulnerabilities, and then implement granular access controls based on the principle of least privilege, ensuring users only have the minimum necessary permissions to perform their job functions. Option B. Rely on the existing audit logs to monitor for suspicious activity and address any confirmed breaches after they occur, assuming the current broad access levels are acceptable for operational efficiency. Option C. Immediately revoke all elevated privileges for all user groups and require each user to re-request access individually, documenting the business justification for each specific permission. Option D. Implement a blanket policy that restricts all users to read-only access for the entire database to prevent any possibility of unauthorized modification, regardless of their role. The correct answer is A. Conduct a comprehensive risk assessment to identify critical data elements, evaluate potential threats and vulnerabilities, and then implement granular access controls based on the principle of least privilege, ensuring users only have the minimum necessary permissions to perform their job functions. Explanation: this scenario is professionally challenging because it requires balancing the need for efficient data management with the imperative to protect sensitive information from unauthorized access. The core of the challenge lies in interpreting and applying the principles of data security and access control within the context of DB2 10. 1. Ensuring compliance with relevant regulations without hindering legitimate business operations. The correct approach represents best professional practice because it prioritizes a systematic and risk-based methodology. By conducting a thorough risk assessment, a professional can identify potential vulnerabilities, evaluate their impact, and implement appropriate controls. This aligns with the fundamental principles of data governance and security mandated by regulatory frameworks that emphasize proactive risk management and the principle of least privilege. It ensures that access is granted only to those who require it for their job functions, thereby minimizing the attack surface and potential for data breaches. An incorrect approach that focuses solely on granting broad access to all users for convenience would represent a significant regulatory and ethical failure. This would violate the principle of data confidentiality and integrity, potentially leading to unauthorized disclosure or modification of sensitive data. Such an approach would likely contravene data protection regulations that mandate appropriate technical and organizational measures to safeguard personal data. Furthermore, it demonstrates a disregard for the potential business and reputational damage that could result from a data breach. Another incorrect approach, which involves implementing overly restrictive access controls that impede necessary business functions, also presents a professional failure. While security is paramount, it must be balanced with operational requirements. Unnecessarily blocking access can lead to inefficiencies, reduced productivity, and frustration among legitimate users, potentially leading to workarounds that bypass security measures, thereby creating new vulnerabilities. This approach fails to achieve the optimal balance between security and usability. A third incorrect approach, which relies on ad hoc security measures without a documented process or understanding of the underlying risks, is also professionally unacceptable. This reactive and unsystematic method is prone to oversight, inconsistency, and a lack of accountability. It fails to provide a robust and sustainable security posture, leaving the organization vulnerable to evolving threats and non-compliant with regulatory expectations for a structured approach to data security. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes identifying assets, threats, vulnerabilities, and the likelihood and impact of potential risks. Based on this assessment, appropriate security controls, including access controls, encryption, and auditing, should be designed and implemented. Regular review and updates to the security posture are crucial to adapt to changing threats and business needs. Professionals must also stay abreast of relevant regulatory requirements and industry best practices to ensure ongoing compliance and effective data protection.